Okay, for people joining this meeting, this is our weekly incremental language development meeting for Wolfram Language. As I've been saying in several of these live streams, the live streams have been a bit sparse recently because we're finishing version 12.1 on the one hand, and on the other hand, I'm personally deeply and intensely working on my physics project, which hopefully will see the light of day fairly soon. All right, let's launch here. Brian is asking, is there an announcement date for my physics project? We were literally just discussing that. I think I'm going to predict mid-March. Okay. I wish it's one of these things where there's just a lot. This physics project, I'm just itching to tell people about it, but it's just there's a lot to say, and it'll get very, very, very confused if it's not said in an organized way. So we are getting things ready, and I hope it will be very nicely presented and all ready to go. And I'm deeply impatient. So if you think you're impatient to get this finished, I'm 100 times more impatient than you are. But okay, combinators.
Yes, I mean, we talked about those a couple of weeks ago and got sidetracked into evaluation control, outermost, innermost evaluation, stuff like that. So I think here the idea would be to just lay the groundwork to decide on the name for the binary application and get the design of the operator symbol on its way, and maybe we could even decide how we would represent the basic combinators.
Okay, so but so what? Okay, so I've got several questions here. I mean, what do we think we're going to do with the combinators? That is, are they going to auto-evaluate? Is it going to be an eval
No,
function?
I mean that is impossible, because I mean all the interesting ones have infinite evaluation chains. So at the moment it's just notation, and then we need a way to selectively apply those standard rules for S and K. Say I would like to apply them innermost or outermost, or apply them step by step.
Right. So that turns into a
I mean, essentially replace repeated, but maybe something that would allow us to specify the order in which these rules get applied, because at the moment I think it's undefined. Right?
Absolutely. By the way, I see a question on the live stream from Ethan about, can you pull in the Google Calendar to the, I think the answer is yes. I think there's a service connection that lets you do that, because I think it uses iCal format. I have not tried doing it. Don't know. But I think it should work through Service Connect. Okay. Look, this whole business about how the evaluation is done, that is the whole story, really, of all of this. I mean, that's going to be, we can have a notation, and that's interesting, but what are we going to do with the notation other than various kinds of evaluation? And I don't even know. I mean, some things like church numerals and so on, they will be stable. They don't evaluate. They're just, but there are other things. I don't even know whether people try and do crazy stuff where there's partial, where there's things where you say, I mean, this is very much of the, 1 minus 1 equals 0, but 1 is represented by a non-terminating combinator expression.
Yes, I mean, if you look at the fixed point combinator y, I mean, the basic property is that y of f turns into f of y of f, but it doesn't stop there. So to actually show that it does, then you would have to selectively apply it, say, just apply it one step at a time, and whenever you have the desired result, you stop. So I don't know how much you can automate this. I mean, you did some of these chains with S terms in NKS, just to see what happens, but
yes.
But you never worried about the evaluation order, and that makes obviously has a big impact on the size of the expressions, because if you do the innermost parts first, then they will usually grow much faster.
What did I do? Do you know what I did for evaluation order? Because I must have, I mean, I did it
Yeah, you probably just use replace repeated or replace in a.
Yeah, but I certainly knew about this issue about evaluation order, so I will have had some control of evaluation order. That's pretty minimal. That's using replace.
Yes.
But the behavior in the course of the evolution can depend on how the combinator rules are applied. Okay, so that's what I did. Yeah, so that's we're exactly right. So this is all I did.
I mean, that's good for identifying interesting cases, right?
Oh, I got lots of interesting cases,
yes.
But what do we think people are going to use the combinator stuff for, other than admiring, combinators? Okay, so we have a combinator. So first question is, you are proposing that we have an infix form that will represent something that corresponds to something like this. Is that correct? That we have a left associative form.
Yes.
Okay. So that would work for any functions. I mean, that you could just say f of, your combinatory application, g, et cetera, and it would compose it in this way, right?
Yes, I mean, it doesn't do anything. It's very similar to, for example, non-commutative multiply, right? I mean, we just provide it for those who want to do interesting stuff with it, but we don't actually do anything with it.
I see. So you're not proposing that the thing evaluate to...
No. Combinatory apply just sits there, just like non-commutative multiply.
Okay.
And the operator form is just, I mean, we need a way to represent it in a nice form without all these bunched up parentheses or brackets.
And what are you proposing using? Small circle or something, or what actual symbol?
Well, that's actually a difficult question. I mean, the problem is that, of course, if you work in combinatory logic, then you do the same thing as you do in arithmetic with multiplication. You don't use any symbol, right? So, but we clearly need something on input, and its representation is not that critical because in output you wouldn't even see it, right? Just like the multiplication dot. But the circle, some form of circle would certainly be possible.
Okay. But so you're imagining people will be typing this, but how do they do the with parentheses, right? They'll have occasional parentheses.
Yeah,
I mean, mostly combinatory applies and some parentheses.
I mean, if you look at the example there, the third one is an example where you need the parentheses, the ABC, the one on yes, right there.
Right. Where you're right associating.
And the middle one you don't need, and so it would remove them on input and on output. I mean, it behaves exactly the way left T has exactly these properties, but it's not a very nice symbol to use for this purpose.
Xylocron on a Coron on our live stream is pointing out this saying that he worked on a project with Todd Rowland about combinators. That's cool. Well, we'd like to hear from Xylocoron. That's a good name. Yeah. Look, I think our primary, it's like our Turing machine function. It's, I wonder whether, the question is, are there actual practical applications for combinators in 2020, 100 years after they were invented? Is there in fact anything useful that we could expect to do? But then we would have to have automatic evaluation a big nest of S's and K's isn't going to do anybody any good. It is conceivable that there is piping along the lines of things like curry that could actually be usefully gotten out of combinators.
Perhaps we need a combinator evaluate together with combinator line.
Yes. Well, but that's the point that the Roman is making, that it's unclear what you mean by that. But the fact is that, when Schoenfinkel originally invented these things, he did it as a form of piping, just like we are using curry as a form of piping. That is to get, the argument of something into the right place, so to speak.
Right.
And
but
the issue is that, we have invented certain kinds of piping, and are these useful? Go ahead, what are you going to say?
no, I was thinking that it would be a function needing a second argument that parameterizes the various forms of evaluation.
I know, but those are, that, as I was saying in a previous one of these meetings, look, I looked at this stuff, what is it now, 40 years ago, and it was really complicated, and a certain amount was known. I don't think a lot more is known today. It was super hard to parameterize in a way that made any sense. Now, maybe we know more now and we could parameterize it better, but right now, okay, we shouldn't go through this in great detail, but I mean, imagine an evaluation front, so to speak, as you go through this combinatory expression. It's got a tree, it's got some evaluation front where things are happening, right? Does that picture make sense, Roman?
Yes.
Okay. So think about it like a breadth first search. You're deciding where are you going to go next, right? It's really hard to say that. Now, by the way, I mean, it so happens this comes up in the physics project in connection with foliations of things like space-time, where, think about it like a breadth first search. Let's not slide into talking about this horrendously complicated topic. But the main point is, imagine you have an evaluation front. How do you parameterize it? I mean, even a very simple thing. You've got a grid of values, like you're doing an Ackermann function, like evaluation, and you've got this two-dimensional grid of values, and you're asked which should you do next, right? How do you parameterize that? I mean, you could do depth first. That's very clear. It's very clear what that means. You can do layers in some way, where you do one variable before where you go through, all of the x values for a given y value, next y value, et cetera, et cetera, et cetera. You make slices like that, or you do other things. But how do you parameterize that?
Well, I don't know, but I mean, it's clear that in theorem provers, they must run into the exact same problems, right? I mean, theorem provers try to get around these infinite chains by cleverly restricting how deep they go into various branches, try to find something useful.
That's a slightly different thing. So the theorem provers, I mean, okay, the reason I actually know something about this now is because this stuff is deeply relevant to this physics project. And so, in fact, this is the, these become things like the reference frames and the observer specifications for relativity and quantum mechanics and things. So it is the main bottom line is that it's hard to parameterize. I mean, people like an inertial frame in relativity is a certain parameterization that happens to be really simple. I think, what were you just asking? You were asking how do people parameterize it where?
Well, it's theorem provers.
Oh, theorem provers. Yes. They don't. What they're doing is that they kind of know, they are trying to establish an answer, right? And so what they do, well, you're saying the question is, if there is a fixed point, can you find it? Right, that's the question. And you could go and generate immensely long word, chains, and go off and get lost and never generate the fixed point, right? And the answer is, I mean, our theorem prover, our equational logic theorem prover can. In fact, we should look at that. I think we have a don't we have a combinator axiom system in the theorem prover?
Not yet.
Okay, but we certainly could have. So that is one approach to evaluation, is to say use the equational logic theorem prover, right, and see if we can find a fixed point that way.
That's a possibility, certainly. I mean, once we have this symbol, we could train the theorem prover to know the properties of the symbol.
Exactly. Look, the fact is, you already know it's a lose in terms of practical programming if the evaluator is a theorem prover. You know, it will be unusable for anything practical because you have no idea how long it's going to take.
It's certainly, but and it will be able to prove only some of the cases. I mean, with theorem provers, with theorem assistants, typically the process is very targeted. You specify very explicitly exactly where you want things to happen, step by step.
Right.
Well, but I mean, we can still do useful stuff like with Turing machines. I mean, we know that it's undecidable, but we can still, for example, look for busy beavers. And I mean, there's a lot you can do experimentally. I mean, yes. So
right.
I think we could have a good support for experimenting with combinatory terms.
Fine. Well, okay. So look, the main point is, what does the evaluator do? Right. And what you're suggesting is we have several forms of evaluator. One form of evaluator might be the theorem proving evaluator, where it uses the best methods we have to try and find a fixed point using theorem proving. Another method might be a depth first evaluator. So maybe the right thing to do is we could have a combinator evaluate, which has a second argument, which is the strategy to use. Mm-hmm. And we just have some named strategies.
Yes, but that wouldn't even be restricted to combinators, right? I mean, the same thing is useful just pretty much everywhere.
No, because for the theorem prover one, we have to have the axiom system.
No, I mean the rule-based one, right? I mean, a kind of repeated with some smarts built in would be useful, not only for combinators.
It would be useful, but I'm telling you, there isn't a good. It's very hard to parameterize that. I mean, I think it's a very interesting language design problem, and it is related to our questions about handling unevaluated code. But I think it's a hard problem. I think we should, okay, so with respect to this, look, let's at least do the curation to find the definitions of all sorts of famous combinators, okay? That's easy enough. And let's plan to put in the syntactic form to deal with combinator apply.
Yes, and then we need to decide on the name.
Combinator apply? I think it should be combinator apply. Or combinator, well, what would be the right, what is the right version of this? It isn't really apply, is it?
Well, I mean, apply is all there is, right? I mean, there's only one operation. And I mean, it's called combinatory logic, combinatory terms. So combinatory is kind of.
I know, but combinatory is, we tend to avoid, I don't even know what the English description of an, I think we should just call it combinator apply and combinator evaluate. What do you think?
I agree with that. I do prefer combinator to combinatory.
Combinatory just sounds like dilatation as opposed to dilation.
And too close to combinatorial.
But then I think, you know, somebody should do the curation task of just collecting the definitions of all these things. The other thing we want is something which will take a string, a traditional combinatorial logic string, and just parse it.
Yes, I mean, that could be a resource function. I mean, that, or we wait until we have a parser generator in the language.
Well, I think we should have, just like with regular expressions, we should be able to do it. I mean,
it's not difficult,
right? Right.
And I mean, that set I have there, SKICBWI, that's pretty much what we need. I mean, there might be others. I mean, you probably already did more research on this, on the origin of all of these.
Well, I mean, Raymond Smullyan has this whole book of combinator. You know, he has this whole book of birds, which
I
has
mean,
a whole.
do we use the traditional named constants, or do we just call them combinator S, combinator K, combinator I?
I would just call them combinator SK, whatever.
Yes. So we don't have to argue about who invented them first.
No, we do not, because we'll never get the answer to that. Because I mean, I do know enough about this to know that it's a bit complicated. Yes. All right, listen, I don't really know what, other than it's a cool thing to do at the 100th anniversary of Combinators. I'm not sure that this is going to be a practical, look, it's one of these things where if we get them implemented nicely, it may turn out to be more practical than we think. But in 100 years, it hasn't turned out to be that practical yet. All right, let's move on here, because I think we've got somebody's pointing out things about cellular automata, and wow, I don't know anything about this. I don't know what this is. Okay, well, that's a picture of a lizard. I like that.
Sorry, can we discuss for a moment the possible precedence that this thing could have, so that we can get moving the process of this symbol?
Oh, that's amusing. This is a neural nets meet cellular automata. That's kind of cool. Okay. Precedence. I don't know. Did you have a proposed precedence in here?
So I think this should be compared to add and composition, and both are very close together in the table. So it's just a matter of deciding where to put it in relation to them.
So if you say F, I mean, let's call this, I don't know what we're calling it. I mean, if you say F dot G at X,
right,
I would assume that you want that to group like this. In other words, you want to turn that into, let's see, the F dot G, the grouping F dot G dot H is a left application grouping, right? So what does that turn into?
Well, F dot G and the whole thing dot H. Right, yes. No, so, you mean that? No, I was thinking about the parentheses. I mean.
No, I mean in terms of functional application, what does it turn into?
Yes, another bracket H.
Like this.
Yeah.
Well, I would thoroughly expect that if I did at X, I would thoroughly expect that to be that thing of X. So I would expect it to be more tightly binding than at. Okay, so what do I think about composition?
Yes.
Well, so what do we think about composition? So composition, if I say F at star G of X, how does that bind even? That binds with the, oh, for goodness sake.
Try at.
Which is wrong,
binding,
right? That's really strange, right?
It's really crazy. I don't understand that at all.
Try G of X rather than bracket of X, because the bracket is already there.
Sorry, what are you saying?
So yes, this is the example we wrote on the left-hand side. So try the same thing, but instead of bracket X bracket, at X. Right.
Okay, that's correct. Yeah, I mean, this one has confused me multiple times, this precedence here. The problem is if you have it so high precedence that it's higher precedence than function application, it peels off all kinds of crazy things.
Yeah, there's probably no good solution, right?
I think that's unavoidable. Once X is there, G of X is treated as a function.
Okay, so the question is between this and the dot, where does the dot go relative, or whatever it is, relative to this?
Right.
Do you have a proposal for that?
I mean, composition doesn't doesn't interact with combinatorial applications. So
can they be the same precedence, like this is for right and left
Probably, yeah.
composition?
probably.
I think dot is closer to add than to composition. So probably we should put this dot precisely between add and composition.
Are you sure?
Not completely, but to me, apply is a form of add.
All right. Well, then maybe it should be the same. I don't understand if it's the same precedence. I don't understand the associativities. What's the associativity of composition? Right, it's left. That's left associative, isn't it?
Well, composition is flat, so it will not matter in the end, I guess.
Okay, but this combinatory apply is not flat. It's left associative.
Yeah, exactly.
So I don't know the interaction between something of the same precedence that's flat versus left associative.
I think if we make it exactly like add, then the first one will win whatever it comes.
Look, I don't know. Why don't you try some things and then try making a bunch of test cases and see what happens.
Okay.
All right, splice.
Yes.
I'm still okay with splice.
Okay, so that's all.
Okay.
Mm-hmm.
Great. Extract with the default element.
Yes. So I think this is an interesting idea, and in fact, I wanted to show that I have that function internally for use in some places. The thing I'm not sure about is the fact that in other cases in which we added a default element, we ended up adding hold rest attribute, which I don't like very much.
Why?
Well, because people thought that you might want to have a default element which is a throw, for example. Exactly. So we made.
I didn't know that. I thought so this is a hold rest thing?
Yeah, first became hold rest just to support that thing. And I think extractors should not be hold something.
I agree. I think it's a mistake for first to be that way.
Right. So an alternative, if people want to throw things from the default element, would be to support a function. Rather than having the object itself, we have the function that takes, for example, in extract the position and returns the object to be placed there.
I'm sorry, I didn't understand that. So how would you get around the first thing? So I mean, the issue.
Sorry. Imagine that instead of x, we had a function f, and then rather than returning x, we return f of the thing in the first argument.
Well, I mean, the other possibility would be some form of thing like this. Because the main issue is this is this is like if, right? But it's okay, so you would argue if. So the point here would be a generic wrapper which says, I mean, this is in the family of splice nothing, et cetera, et cetera, et cetera. This is a generic wrapper. Is it semantically well defined? That if it's used, will unpack itself, but otherwise will not. I mean, that's somewhat similar to the way that delayed is used in web deployments.
Let's see.
To me, that seems like a better solution. I mean, to have some general mechanism which says certain functions can take things which are delayed. What other functions might take that? I mean, and so generally the thing would just be, I mean, delayed would have, what would be the semantics of it? The semantics would be, yeah, I mean, the semantics are just defined by the function, just like nothing and, despite Itai's attack, I really think that this idea of spliceable is a good idea for functions. That we can use splices as a way of inserting things into a variety of functions by just defining those functions to be spliceable, just like we've been very successful with numeric and with listable, both of which are just like do the right thing type attributes.
Somehow with splice, it feels as if the important thing is to specify inside the splice itself what's the heading to which it should splice. Just an independent direction.
It's an independent direction, right? But I think that the auto splicing is really worthwhile. I think people will find it really useful. So, I mean, auto de-delaying would be another thing. I personally, I think this is the right kind of approach, and it will be, I think, worthwhile to review our various functions for which ones could take this. I mean, these are things where there is what is the characteristic? It is.
And I think it's a default element for extraction when the element doesn't exist.
You think it's that specific? I mean,
I think it's very specific. We have the same problem in lookup, and lookup also got a hold attribute to support this type of thing.
Oh gosh, that's horrible.
Yeah, and we have had multiple complaints about that.
Well, it's horrible. We shouldn't. I don't know how these things happen because we never. I mean, I would never have approved that. Oh gosh, whatever. It's a mistake. It's a mistake. We shouldn't do that.
Yeah, extractors are functions that have to do their thing immediately without any delayed form. And in extract in particular, we cannot have hold rest because we
well, so let's look at the idea of delayed. Okay. And again, let's inventory what other functions could use it.
What about this alternative of a function that would take the position? That's a bit more flexible because function itself has a hold attribute. So whatever we put inside is safe. And it gives this freedom of, I'm going to use a different default at different positions.
I see. I mean, it's a nuisance, I think, for people, because I think most often they're just going to want to put a particular thing there.
And then it will be just function of that thing. It's just function that ignores the position.
I understand that. But I mean, we cross that bridge a little bit with already putting first there.
That's true.
I agree that the function thing is an interesting idea. And I mean, we could conceivably do that with an option. What options? We have such things. Missing, what do we call it?
Missing behavior.
Yes. Okay, look, let's inventory where we could use this delayed thing, where we've already got things like this, whether we could use a missing behavior option. I think we need some more information.
Okay.
We are almost out of time here, but what is this? Oh, this was me and side effect stuff.
So the main thing here was to point out this alternative implementation, table while, which I find interesting. So I think the idea is to do repeatedly things with a test. And the same idea was suggested in this function repository function, table while. And it has the freedom of having a different test per level, which I find quite interesting.
Which one?
The function of the function repository, table while. So
I see.
I guess the suggestion here is to modify a bit your suggestion of a repeat test to this other type of approach of table while. And I think we have discussed other times this. The idea is to generalize the iterator language to include conditions.
Yeah. By the way, Ethan is asking on our live stream about neural net stuff, and I don't know why maybe the neural net team should do a session with people. I think it would be interesting. So Can we get, Devin, can you get that suggestion made, please?
Yeah, sure. Yeah, I can forward it.
And otherwise, yeah, we could. I don't know why we haven't been live streaming those meetings. Actually, I think some of them have been very. Some of them are pretty procedural, but that's another thing we should put on the list, is to live stream the machine learning update meeting.
Sure.
There's lots of stuff going on, so it's just not so visible. Okay, so the question is adding conditions to iteration constructs. And is the proposal here to generally have something which is some kind of condition in an iterator? That seems complicated.
It seems, yes, I do agree. I guess my point is trying to get something a bit more powerful than the idea of a single.
Well, I mean, the obvious thing to do is to replace the list iterator with something else called, conditional iterator or something, but that's a bad name. But wherever we could have a list and table or whatever, to be able to have that symbolic object.
I see.
Or alternatively, see, because an iterator has several pieces. I mean, an iterator, you could as well have a function that says, I don't know, square the variable each time or something. Okay, but the basic category here is to make the iterators more sophisticated. But then the other question is, in terms of the termination condition, what information do you have when you test the termination condition? Right, because our iterators have the feature that they have everything in scope, which means they might have a previous iterator value. They don't, for example, have the value of the payload.
I mean, we're talking about iterators in the sense of object-oriented languages, right? Where you have something that says, create this iterator, and every time you call it, it produces the next value until it tells you that it's done. That is a very powerful concept, which we don't have.
Yes.
We have had meetings about that alternative approach, and that's more powerful than this. This suggestion is simpler. It's just having this test, which gets the value of what has been produced, not the value of I itself, but the value of the payload of table at each iteration.
Yeah, I don't. Yeah, I mean, in Roman's point about okay, so I mean, Roman's point is just have a function that you call on what to get the next value. What do you provide it?
It
Like
doesn't have any arguments. I mean,
well, that might work in a language where you just have random variables flapping around. But
it has internal state. I mean, it's you create an iterator. For example, you might create an iterator that produces primes. And once created, that iterator is a parameterless function that every time you call it, it produces the next value.
No, I understand that, but that's different from what we're doing here, where you have an iterator where we have a two-step thing, where we have an iteration variable that is then used to evaluate a payload.
I mean, you would then apply a function to that iterator to produce.
I understand. It's a completely different style of programming than what we have.
Yes.
I mean, the case that we have, look, really, the correct thing here is actually something different. I mean, the correct thing would be some kind of thing that says table, and then, something like, I don't know, something like this, value while this is probably not quite right, but I mean, right now, I don't even know what it does. What does it do if you say table return if I greater than 6, return I. I mean, again, this is very what does this do?
We document that we should use throw and catch for this type of thing.
Okay. But I mean, so, okay, so you're proposing, so there, if we do throw, catch, you say this is going to be 6, 7, whatever. Okay. But now my question is, what if I wanted there to be a condition that caused the table to terminate? Right? I keep tabling up until that condition is hit, and then in effect, it's returning a bunch of nothings after that. I mean, I could do that right now. I could say table if, I greater than 6, nothing, otherwise I. Right?
Right.
But so, another possibility is to have something in the payload that causes early termination. Now, that might cause trouble because we can predict right now how big a table is going to be, whereas if we do that, we cannot predict anymore. But if you return nothing, you won't be able to predict either.
Well, the nothings are removed a posteriori.
Yes, right. But I mean, so the question is, what is the difference between putting it in the iterator and putting it in the payload? And if we're going to have a function applied to the payload, I'd prefer to have it with the payload. Because if we put it with the payload, we fully expect that the thing will have access to the payload value and I and j, and the iterator variables, basically. That would be the natural thing to have it have.
Mm-hmm. I guess I was trying to align this with take while and for while, nest while, etc.
Sandra on our live stream is asking what happened to his idea about associations in iterators. What has happened to that?
We had a couple of meetings in the LCC series. I think it's still under evaluation.
I see. Okay, fine. Just a different branch.
Yep.
I don't know. I think this is the wrong time in our cycle, so to speak, to solve this problem. I think that with respect to this, okay, look, there's decorating the iterator, decorating our iterators, there's decorating the payload, and there's completely different approaches, like the iterator function approach.
Right.
I think it's worth looking at decorating the payload.
Okay.
I mean, I'm thinking, look, clearly, for some things, decorating the payload is easy. Like, for example, if I do this, that's easy, right? I mean, honestly, this is pretty easy too. But, well, this doesn't cause termination. This just causes...
Yeah, I mean, it's horribly inefficient.
Yeah, but yes.
I mean, there should be something like return that actually tells it to stop.
Right. Sandra's commenting on thinks it's better to decorate the iterator. The problem if you decorate the iterator is it's unclear what you get fed. And whether you get fed, for example, the values of iterators, whether you get fed only values of iterators within that iterator in the hierarchy. So for example, you can say I, 10, I, j, because by the time, j, 10, I, j, because when j's termination condition is tested, you already know the value of I. And so one of the claims would be, when any of those are tested, do you know the sort of triangular inner values of the iterators, and do you also know the payload value? And unfortunately, in these cases, just you just have as essentially evaluation of variables, the values of the iterator variables, but then to get the payload, we presumably have to apply a function, because we're not supplying the payload as a dollar payload value or something value thing. You know what? I think this is not the time to solve this problem. I think it's somebody's asking about automatic differentiation. Yes, it is being worked on. And it is an interesting language design problem. Very interesting language design problem, which we will no doubt discuss in future live streams. All right. Well, this has been a little bit of a thin meeting, but yeah, these will thicken up greatly once 12.1 is out the door, and once I have a bit more time to devote to these kinds of things. Okay, let me go back to trying to figure out the evaluation scheme for the universe, so to speak, which turns out to be shockingly similar to the problems that we have here, and hard. All right, talk to you all soon then.
Okay, bye.
See you. Bye-bye.